My name is Leonard, and I'm going to talk to you today about a little piece of my PhD thesis on climate change and increasing disinfection byproducts in Colorado. The motivation of this work is on the fact that Colorado's climate is changing. A recent report prepared for the Colorado Water Conservation Board has provided some alarming trends and predictions for Colorado's future. Specifically, in the past 30 years, there has been an overall warming trend of 2 degrees Fahrenheit of temperature. In addition, increased drought. But interestingly, the annual precipitation has been variable with no clear trends. However, in the past 10 years, overall, there has been below average snow water equivalent precipitation. And in addition, there has been earlier snow melt by 1 to 3 weeks in the past 30 years, which has led to reduced spring snowpack, which has concerns for water storage, but also hydrologic issues. And so this means there's going to be a new normal in certain locations of Colorado. And so if we look here at the snow water equivalent of just some 8 major river basins of Colorado broken up by northern and southern Colorado, we can see that overall there's similar behavior between the two locations, but the report had shown some alarming trends overall in southern Colorado and has predicted them to be at the highest risk of decreasing precipitation and likely warming as well. Now, all these variables, climatic shifts, can lead to other issues that we are experiencing in Colorado, specifically with increasing temperatures and drought. Bark beetle infestation has worsened and led to large-scale tree mortality across Colorado. And this leads us to the major question of our research, which is, are disrupted watersheds experiencing worsening water quality? And we wanted to focus on water quality because some of the impacts in forested ecosystems because of increased temperatures and drought are increased canopy losses, evaporation, and organic inputs. This can lead to shifts in our soil and water chemistry, which can lead to larger hydrologic and biogeochemical cycling issues in our forested ecosystems. But interestingly, the observations can vary on a watershed basis. And this comes back to what we alluded to already, where some parts of Colorado will be experiencing different impacts depending on the climate experience. Our study focuses on disinfection byproducts because of what we just discussed, where due to increased tree mortality, we might start to see increased organics in our surface water. When these organics reach our water treatment facilities, during the disinfection process, the chlorine will react with the organics and form disinfection byproducts. And the 2 major groups of disinfection byproducts, or DBPs, are total trihalomethanes and haloacetic acids, recognized with maximum contaminant levels of 80 and 60 micrograms per liter. So the study tasks were to first analyze historical watershed climate data through SNOTEL stations, and then characterize the surface water disinfection byproduct concentrations, which are provided by most municipalities during their typical water quality reports. We then wanted to determine if there were any significant trends and correlations between the climate and water quality data. With the climate data, we assigned climate indices based on annual values determined here based on precipitation and temperature. We will focus today mostly on frost, ice, summer, and snow-adjusted days per year. And snow-adjusted just means the snow water equivalent. And we will only focus on a few interesting watersheds today, first starting with the Colorado River Basin and just a few sub-basins, which we will see here as the Colorado headwaters, the Blue, and the Plateau Subbasins. And you can see the SNOTEL stations as the circles, and then the municipalities treating surface water in the red stars. And if you look to the left, these sub-basins each showed significant trends in either all or some of frost, snow, and ice days per year. And the ice total days are shown in the y-axis. Now, if we look at the disinfection byproduct concentrations, and we'll first focus on the Plateau Subbasin, we saw that there were significant increasing trends of either total trihalomethanes and or haloacetic acids. And we're only showing total trihalomethanes. And so if you don't see a significant value for a municipality, that means it was significant for haloacetic acids, which just are not shown in this presentation. Now, these increasing trends are concerning not only because of the trend, but also because you can see at some times they have exceeded the maximum contaminant levels, which is associated usually with the peak flow associated with spring or summer snowmelt. And again, if we look at the Blue, Eagle, and Colorado headwater subbasins, again, we saw increasing trends in total trihalomethanes and or haloacetic acids. Now, if we switch to just another, a southern watershed, the Gunnison River Basin, again, we saw significant decreasing trends of total annual frost, snow, and ice days per year, whereas summer, as you might have noticed by now, was not clear with any trends overall. Now, again, if we look at the municipalities treating surface water, we saw significant increasing trends of the disinfection byproducts. And I'd like to point out Crested Butte, where consistently during peak flow, they have exceeded the maximum contaminant levels of these disinfection byproducts, which is concerning. Now, overall, if we plot the statistical findings of the disinfection byproducts, there's a lot of scatter. Overall, we see across the board some increasing, significant increasing trends, but also decreasing or no trends. But if we look at just overall, regardless of whether there's a significant trend, we have seen with both haloacetic acids and total trihalomethanes, over 100 municipalities have exceeded the maximum contaminant levels at times, which is alarming and shows that there is a bit of an issue here that we need to address regardless of the trends. Now, if we just look at statistical findings comparing the climate and disinfection byproduct data, at times there were significant correlations between all of the climate indices and disinfection byproducts, but the most significant and just overall the most correlations were found between the total ice and frost days and the disinfection byproducts. And the Colorado report shows trends that agree with our findings, which is shown to the left here, especially between 2000 and 2010. And then further, other studies have shown that changes in snowmelt timing, early snowmelt frosts, and late season drought can enhance carbon release and likely disinfection byproducts, as we're seeing in the results in this study. Now, it's worth mentioning some limitations of this study. First, the fact that not all climate data is available, and it's limited in locations, which made it difficult to characterize all watersheds of Colorado. In addition, sampling events are not consistent across municipalities. And even more interesting, not all municipalities monitor their organic carbon inputs, which could be a very good precursor for disinfection byproduct formation potential. So the next steps would be first to monitor and define at-risk watersheds using some of the variables we've discussed in the study today. And then from there, it would be great if it would be good if climate trends could be used to predict disinfection byproduct increases for at-risk watersheds. And all municipalities should explore treatment alternatives, especially during these peak disinfection byproduct concentration periods associated with peak flow in the spring and the summer. And just for an example of what this could look like, if we use a publicly available forest health index, which basically is just a group who uses climate data to assign a value from 0 to 10 on how bad the trends have been in certain variables such as temperature, frost, bark beetles, and so on. Now, just if you see visually with some of the subbasins here, we can start to visualize perhaps if there's certain watersheds that are at more risk than others to form higher concentrations of disinfection byproducts. And so this could be a proactive way to address the issues that we've observed in this study, where there are just overall increasing trends and instances of disinfection byproduct concentrations. So with that, I would like to thank you for listening today and just acknowledge the Department of Energy for funding my research, but also the Colorado Department of Public Health and Environment, where the water quality data reports are publicly available, and then the Natural Resources Conservation Service, where the SNOTEL climate data is publicly available. Thank you again.